Welcome to the Gregarious Marvel podcast. Once again, this is Chris introducing you to an interview that Cate and I conducted at Web Summit. We're slowly clearing our backlog of interviews, and then we'll get back to some links shows in the new year. But this is an interview we did on the show floor. I've tried to reduce as much background noise as possible with Kolton Andrus, the CEO of Gremlin. I've actually written about Gremlin before. They specialize. In fact, they probably sort of kickstarted the whole trend, practice, whatever you want to call it, of chaos engineering. This sort of measured approach to breaking and measuring production applications. And we hope that you enjoy the brief conversation that we had.
Yeah, a bit about the company. So I started doing this for Amazon.com about 10 years ago. We were on the team making sure the retail website didn't go down. Yeah. And when Amazon goes down, tens of thousands to hundreds of thousands of dollars of lost revenue a minute. So it's well worth the investment. When I joined, it was fundamentally reactive. So you got paged. How quick can you get on the call? How quick can you triage it? How quick can you fix it? But that only gets you so far. Somewhere between 3 and 4 nines, 3.5 nines. You want to get to that 4.9 and above level of reliability, less than an hour of downtime. You can't just be fast at fixing it when it breaks. You have to prevent it from ever breaking. And so that was where we came up with this idea of, it wasn't called chaos engineering at the time. It was just how we did engineering. But Jesse Robbins in the early 2000s, he pioneered this idea of game days. He would go into the data centers, pull cores, shut down racks, see what would happen. And you test both socially how the company handles it and technically how the software handles it. So we took that and we built a tool and a platform around it. We wanted it to be safe. We wanted it to be repeatable. We wanted to automate it. We wanted to be able to really understand it better. So we did that. We had hundreds of teams use it at Amazon. DynamoDB used it before they launched and found and fixed some consistency issues with this approach and my tool that I built there. And then I worked on performance and some other stuff, and I wanted to go deeper in this space. And so Netflix, while I was at Amazon, had spoke about Chaos Monkey. So I thought, this would be a great place to learn more. So I joined Netflix, and I show up, and it turns out that Chaos Monkey and Simian Army really weren't good enough for what we needed. They didn't scale. They had a large blast radius, so sometimes the experiments would cause unintended failures. And so we really had to... So I had to build a new platform. So we built one. It's actually very similar to the application level fault injection that we just released. But it allowed us to test single users or percent of users. We could test very small and then scale it up as we went. We could test it kind of anywhere within our platform. And so we saw Netflix. When I joined, they were at about 3 nines, and we got to 4 nines. And then my team and the teams underneath me, so we owned the proxy and the API, we got paged 25% less every year I was there. So we saved a lot of time and we saved a lot of outages, and customers were happy. So having seen this approach be successful at Amazon and Netflix, we felt like the rest of the market would really want this. And so my co-founder, Matt, he worked with me at Amazon. You know of Tammy. She worked at Dropbox. She was doing this there. Some of our support and success people came from Google and AWS. And so we took this idea and we built the tooling, the same types of tooling we built for Amazon and Netflix. And then we've been teaching people how to do this approach.
Can I pick up on one thing you said there?
Yeah.
It's played on my mind. There's sometimes criticisms of chaos engineering about, are you really recreating random events? And one thing you said there was Netflix tool didn't really work because it had too many unintended consequences.
Yep.
Isn't that entirely the point?
No, it's not. So it's always a balance of risk.
Okay.
So actually, this is one of the problems with Chaos Monkey. Everybody thinks chaos engineering means randomly breaking things. I disagree with that. That's not how we did it at Amazon. We treated it like an experiment. We had a hypothesis. We wanted to measure that hypothesis. We wanted to validate that the system did what we thought. If you're doing it randomly and you're not measuring it, you're doing it wrong.
So is the name misleading?
The name is misleading. It's not applying chaos to engineering. It's engineering for chaos. That's really what we're doing. We're taking the discipline. It's not as sexy. That's the problem. And that's why, look, I'll take the term chaos engineering, or we can call it resilience engineering. We can call it disaster recovery. I don't really care. But that crux of treating it like an experiment and being able to scale it up. So one key concept there about mitigating mitigating that risk is the blast radius. So we always want to run the smallest experiment that'll teach us something. Usually that's against a single user or device, a single host, a single container. And from that, we can see, does the system do the right thing? If it doesn't, we're done. We go fix it.
That, though, in terms of anomalies with other users or other service providers. Like you mentioned, you can do it in a micro kind of level.
So the application layer is what's required to have like request level granularity. So being able to know about the system's users or devices. At the infrastructure level, it's hosts and containers. That's the level we work at. But there's a wide variety of failures that can occur. It's more than just rebooting hosts. That's kind of the most naive failure in my opinion. Like what happens when your CPU's bound? What happens when there's a memory leak? What happens when a disk fills up? What happens when daylight savings happens? What happens when processes die? And that's kind of the, can I handle what happens to me? And that's level 1. Like level 0 is like, I'm going to randomly break stuff and I don't know what happens. Level 1 is like, cool, I can handle the types of things that can and will occur to me. The next level is, can I handle bad things that happen to my dependencies? So S3 goes down, DynamoDB gets slow, we lose a region in AWS. I'm not picking on AWS. Any cloud provider or service applies here. Many internal services. As we embrace microservice architectures, we have distributed systems, pieces could fail anywhere. And we want to ensure that our customers always have the best experience. And so to prepare for that, we have to see how the system behaves when those things happen. So we have to test them. And then that makes it so we can gracefully degrade. And ideally, the example I always give from Netflix is like, if the recommendation service is down and I can't tell you your personalized list of movies, that shouldn't stop you from watching a movie you know you want to watch. Like search should still work. Maybe I give you a canned list of the top 100 movies, but you should still be able to do the thing that you care about doing.
And you mentioned having clients in enterprise and retail. Are there other spaces that you're focusing your efforts on?
Finance has been a huge one. Every big bank in the U.S. is talking to us or spending time with us.
Around speed as well.
Speed is important, and the load testing is part of it, but at the end of the day, in the finance world, the e-commerce world, or the SaaS world, the cost of downtime is easily quantifiable, and it's a lot. And so if it becomes a question of, can we save a 30-minute outage? If that costs you $1 million, in addition to the engineering time and the customer trust, it's well worth spending some time and effort to prevent that from occurring.
And this is just purely a clarity question for me. When you talk about predictive analytics, predictive maintenance, are you also doing the repairs for those for the anomalies that get through?
No. So we're giving the engineers the tools to safely run the experiments, but they know better than we how to fix the system. Sometimes it's not a technical problem. It could be a business problem, like recommendations versus digital rights management. They both might throw a 500, but DRM is a business outcome. It has to fail. That's what it's supposed to do. And so you want to give the engineers good tools. But one thing we've learned is, in the beginning, we didn't want to be prescriptive. We built a very generic platform. It could do a lot of great things. What we've heard over and over again this year as we've been teaching people is, can you just tell me what to do, guide me through it. So we're taking a lot more of the knowledge that we have as experts and we're building it into the tool so that we can guide people on what to look for and then maybe how to think about it.
So would you see that as really skilling up people in their own workplaces?
Yeah. To be a good engineer, you need to think about these failure modes. You need to handle it. So really, it should be part of the development process at all levels, and you walk away with a deeper understanding about how it fails and how you should handle it.
On that, how do engineers integrate Gremlin? Is it an SDK or...
So
what's the overhead?
So at the infrastructure level, it's an agent that's installed. It's a Linux, Debian, or RPM package, or a container, and containers are first-class citizens. We have a lot of customers testing and hardening Kubernetes environments as they try to move workloads over there. And so that communicates with our control plane. That's some of the safety features to ensure we can always roll back and clean up attacks, or if things go wrong, we can halt it and make sure that things get cleaned up. And then we have a good web interface, because one thing we learned at Amazon and Netflix is if you want engineers to do the right thing, you need to make it easy. And we have a good API, because once you've done it manually, you need to automate it. You need to build those tests into your CI/CD pipeline.
And are you finding when you're dealing with the engineers, is there a significant knowledge gap?
we do a lot of teaching about chaos engineering and how to do it safely, things like the blast radius, things about how to create experiments and measure them. But they're the experts in their system. And so they know the subtleties, like they know how to whiteboard it, they know what could go wrong. And so really they're key in that process. And like you mentioned, them learning and understanding their system, this is the whole social aspect. There's a reason we run fire drills. And that's because when there's an urgent situation, you want it to be muscle memory for people to do the right thing. Most companies I've been at, the on-call training is, here's your pager, good luck. Like maybe there's a run book out of date.
But actually, a lot of engineers from a business end will have a perspective of what success is for an application in terms of KPIs and things like that. But do many engineering teams actually have measures for failure as well?
Well, you still use those KPIs to help know whether the failure manifests to the customer.
That's a failure of a business process as opposed to a failure of a system.
If it's a customer-facing failure, it's a customer-facing failure. Now, how that manifests, like Slack might go down because some service deep in its bowels had an issue that bubbled up. That's going to affect a KPI. It's going to affect customers. Now, there might be some secondary measures that help you understand it, but the business measures are the most important ones. And when we did these tests at Netflix and Amazon, we would never break those KPIs. And if we ever broke them, that meant we halted the experiment immediately because we just found something super critical because it could break those KPIs.
What would be the biggest issue, let's use that word, that Gremlin has helped a customer uncover? As explicit or as implicit, as clear or as vague as you want to be.
There's a few classes. Yeah. So there's classes of verification. We think the system behaves this way. Now we know it behaves this way. That engineering confidence is huge. Most engineers go into their peak with a 50% confidence their system's going to behave correctly. We were able to get to 80, 90% confidence. You sleep easier. You're more comfortable. It's very useful in validating that your alerts and your monitors are doing the right things. You'd be surprised how many outages happen because somebody's dashboard is set up wrong or somebody's alert wasn't tuned correctly. Then we get into key parts of the system. At the small scale, maybe I have a fallback. Maybe I have a cached response. But if I haven't seen how that looks on a customer device, maybe we don't parse it well. Maybe it doesn't look correct. And so there's a lot of value in ensuring that end-to-end test works correctly. When you're testing at scale, a lot of engineers create timeouts for when things look happy, and they don't actually protect them when things go wrong. You have to see the system under duress to correctly tune your timeouts, your thread pools, to make sure you're rejecting traffic when you're overloaded or backing off of downstreams.
Do you let people simulate things like bad network connections?
Yes.
Especially on mobile applications and stuff
yes.
like that. It's often a big assumption that everyone's on a 10 gig connection, in an urban area or something.
I was thinking this the other day. I was on some airport Wi-Fi, and there's an app that I use at home that's very snappy, and it was painful.
I tried to upload a podcast episode last night, and it timed out, but said it had uploaded, and then when it was supposed to be released last night, I was like, there's nothing there.
So that handling that failure correctly. That's a perfect example of what we care about.
Yeah. And it's a real pain point for a lot of enterprises. I mean, you mentioned, I think I heard you correctly, mentioned the word of 2018, AI. Is that a word? Acronym? Are you using it? If so, how?
So here's what I'll tell you about. The long-term vision is that we get to the point where we can automatically discover issues for our customers. And I had the opportunity to do some work on this front. There was a paper called Lineage-Driven Fault Injection by Peter Alvaro. So he worked with me. He was my professor intern at Netflix. And we built a proof of concept of that. And we were able to, on the background of 0.0001% of Netflix production traffic, explore the space of failures to determine whether or not things work correctly. And one of the keys there is, how does the customer view it? Because that's what really matters. And so you have that success criteria to determine the fitness of your function. You're injecting failures thoughtfully, not randomly. So we had an algorithm about where do we think there's a lack of redundancy, and it involved a SAT solver and going through some iterations. We had some machine learning as part of that to categorize different classes of users and different interactions, because those interactions touch different services and fail different ways. But that's a lot of where we're building toward with Gremlin. What I've learned is the market's not really there yet. The application level is required to get to that level of granularity, and that's cutting edge for a lot of people. The infrastructure level is pretty well understood. A lot of people are getting value. We thought people would jump on application. They need to figure it out. They need to understand it. Once that's in place, we can start doing these more automated approaches.
Do you think, because I've read some of your articles, it seems like, where Gremlin incorporates AI might be a year, 2 years, 3, down the road. But maybe you can talk to, we talk about the cost of downtime a lot for proactively testing for failure. But I know you have some interesting ideas on why that's important even for AI, right? To be able to test it.
Testing AI.
Yeah, testing AI with a chaos engineering mindset. Maybe not even with the Gremlin platform, but do you have any, maybe, because I know you're interested in AI, and have you seen any of that before? Like people talking about...
cynical about AI.
You are cynical, yes.
So there's a lot of trained monkeys.
We're going to save everyone from saying it. We're going to break it.
I did an interview with an artist actually recently who did a project called Frankenstein AI, where they intentionally tried to create something that was evil, and the more interactions it had with humans, the nicer it became. Which was
that's the opposite of social media ones, right?
It was quite interesting, and it was an example of how, if people are nice to something, it gets nicer. If people are nasty to it, it gets nasty. It was well, that's very human, actually.
Yeah.
We've, or I know in my case, I've interviewed a lot of startups that say, oh yes, I'm in the AI space, and I say, okay, let's break it down. What are you actually doing, and how are you doing it? In a not secretive way. What are you sharing? Oh, we haven't really done it yet. We're going to do it though. And so you've got people doing those tasks that you're saying your AI is doing. Maybe it's automating business cards or something. We do see a lot of that in startups. Yeah.
Well, and that's one thing I learned at Netflix. So we went to the machine learning team. We said, cool, we need your help. And our thought was this kind of naive, we'll just rub some ML on it and it'll all work. And I got into tagging and labeling and how difficult it is to actually quantify your features. And the answer is it's harder than it looks. And so I think there's a lot of opportunities as we have scale of data of our customers, the types of outages they're experiencing, types of experiments they're running, that we can learn what to recommend and how to guide people. And that's very much in line with what we're looking to build this year. But not yet, just to be honest.
You need the data first before you can do anything.
Yeah.
It takes a few years to get that.
On that, you said this year. I mean, this year is actually only 6 weeks.
2019.
But what's on the roadmap for the next 6 months?
So very much so building out this recommendations. Before we get to the AI stuff, there's plenty of things we know that people should be doing and that we can advise them. And so today the platform is very, put it in the hands of an engineer. It's a Swiss Army knife. They can take it. We want to lower the barrier to entry. So how to run a game day, how to run an experiment, how to measure it, how to ensure that it behaved the way you expected and quantify it. There's a lot of those valuable building blocks that are important that need to be in place before we can go do the more advanced things.
And for the engineers out there, is there a free tier that people can experiment with, or is it straight into kind of enterprise deals? Or
Today we offer a free trial.
Okay.
You talk to our team, we give you a demo, full access, 30 days. I'll let Adam tease some things down the road. There might be some changes.
Can we maybe we can liaise and document that appropriately?
Yes. We do have a free
because it is something
tier coming.
I think Dzone would promote that through their own networks as well.
Oh, that'd be great. Yes, we'd love to chat. We also have a Kubernetes integration, which I know is always buzzy for people. So,
are there any announcements that we haven't mentioned of what you're doing at the conference that you wanted to talk about? I know you were speaking.
I get the opportunity to be on the growth and the main stage, which is an awesome opportunity. Actually, I just got done with the mentor hours.
How did you get all that? Just out of curiosity. Did you apply?
They've
been nice.
I did them 2 years ago.
Yeah.
The mentor hours were great. That's really an opportunity to pay it forward to founders that CEO to CEO, here's what you need to know. Here's the straight talk.
But also, to be fair, I, as a tech journalist, get a bit sick of tech events that are not really tech, whereas actually a product like Gremlin really is. And so you're talking about trying to lower the barrier, but actually a lot of the companies here are probably that audience. who are like, well, that sounds interesting. I don't understand it.
Yep.
So,
But we continue to do a lot of teaching.
Yeah.
You know, that is the new marketing,
That's pretty
is advocacy and
Yeah.
teaching engineers. And so, you know, we believe the rising tide floats all boats. And so we're out there, you know, Tammy and Anna are doing a lot of great work here where we'll teach people how to do it and we'll help them when they need help. But just evangelizing has been a good amount of our time.
Do you see a time in maybe, I don't know, the next decade or two where you're automated out of your roles because you've got so successful?
I mean, if it's our platform that automated us out of it, then I don't have any problem with that.
We can dream. I wouldn't mind when people say take my job. I'm like, okay.
I think
as long as I get paid.
as you continue to have more distributed systems, more microservice architectures, everyone wants to be like Amazon and Netflix.
Yeah.
They're going to inherit their problems.
Yeah.
And so this is going to become just the way we build software.
Amazon and Netflix have not stopped hiring, so
Yeah, well, go look at the number of chaos engineering job posts that have come up this year, because there's hundreds, and there are not hundreds of chaos engineers.
Oh, that's interesting. Yeah.
People need to become chaos engineers because it's going to be one of the new DevOps SRE
it's all
roles.
basically the same. So I do a lot of, on the other side of journalism, because tech journalism is fun but doesn't pay the bills really. I do a lot of tech writing, documentation work, tutorial work, things like that. And there's been a nice increase in the whole area of, I'll sort of loosely group into like software craftsmanship, kind of basically making software better in many ways, be that stability, be that understandability, etc. And finally, it's taken a little bit of time, but at least engineers are now taking it more seriously as well. So.
It's always one. That's the problem we have is right after an outage, everybody cares about this.
Yeah, for sure.
But if things haven't broken recently, there's always features that they want to get out the door.
And this is a VC model problem.
Just like security.
That's a whole other conversation.
Well, and it's the irony there is it's like if you did this, you know, an hour a week, you would save yourself 10s and 20 hours every time there's an outage, and it'd be easier to plan for and easier to schedule. But
Venture capital pays for features, not stability. This is always the... Anyway, so that's a personal...
my VCs pay for stability.
Yeah, but that's because they're
Don't say it away.
Well, and it's also that people are used to monitoring tools. Like, that's pretty standard. You don't have to convince them of that. But that's totally reactive, right?
Yeah.
And it's already...
It tells
problems
you about a problem you already had.
Totally, yeah. So it's actually, if they get monitoring, it seems like it's an easy conversation to say, maybe you should start being proactive, you know?
And that's an interesting question. Are there any planned or even partnerships you could see with companies like New Relic or something like that?
So we have a Datadog integration.
Okay.
We're working on a New Relic integration. Tracing is on the roadmap with the open tracing work. Maybe Honeycomb. And then some partnerships. Actually, we're an AWS partner, and all of the cloud providers are very interested. Their customers are asking. They care about this. So those are the places I see us partnering this coming year.
Sounds like there's a lot of opportunities for growth there. That's exciting.
And that was Cate and I's brief interview with Kolton Andrus on the show floor at Web Summit this year in Lisbon. You can find more about Gremlin at gremlin.com. And if you enjoyed the show, you can find previous episodes at gregariousmammal.com/podcast. Support the show at /support. Find us on Facebook, facebook.com/gregariousmammal. Rate us, comment, just tell the world, and especially us, that you love the show. We'd like to hear from you. So until next time, thank you for listening.